Hello and welcome to ATG 4950. In this chapter, we will address product testing and evaluation. The chapter will include the different testing methods, their applications, objectives, in addition to some of the tools or methods within each type of testing. The product survey and customer feedback ensured that the product is acceptable to the one who shall use it. The product has to be within the preferences of the target market, otherwise the product will not sell. So we are looking actually to make sure that the product will be acceptable in the market before we release it. That's why to begin we took the survey and we collected the information needed. We analyzed it to make sure that this is what the customer needs. So we used the customer survey to come up with different product specifications, which was mapped to engineering design specifications. In this chapter, we will be learning about testing methods for these specifications. But before that, let's define product testing. What do we mean when we say product testing? Product testing is a measure performed to determine the functionality, reliability, usability, safety, and efficiency, and other factors or functions or other attributes to that product. It is an important process, but unfortunately the most tedious and expensive part of the whole research and development process. Some of the major testing methods that can be identified are the non-destructive testing, which is testing that does not destroy the test object, and destructive testing, which is a method of testing that will be that will put the sample actually the sample object under certain circumstances until it actually fails. Then we have other testing methods that we use. It can be called as non-destructive, sometimes destructive, so it can roll under any of these two types, major two types, like functionality testing, which is used to verify whether a product meets the intended design specifications and functional requirements. We have hardness testing, and we have usability testing. The Center for Non-Destructive Evaluation at Iowa State University listed some of the applications for the non-destructive testing, which is listed in this slide. For example, we have the screening and inspection of incoming material. So when you receive a material in a manufacturing environment, or even at your home, when you receive a material, actually you do testing or inspection for those material to make sure that they are not broken or they are functioning well or right. Then we have product development, and that's actually what we do. We are going to use our testing, non-destructive testing, for our product development. I don't expect any of our teams to use destructive testing and destroy the prototype or the product they developed, but I'm assuming that even if you want to test it to the maximum, you can add loads. For example, if you are making a table and you want to make sure that the table can hold the proper load, you don't have to put loads on top of it until it fails or it breaks, but you can say that it has been tested up to 200 pounds and it can hold 200 pounds. So you don't have to put loads like 300, 400, 500 pounds until it breaks to make sure that it will withstand that, but you can say it has been tested up to 200 pounds in your report when you do that for your product or in the product development that you have. And this is just an example that I'm giving you here for the inspection or the testing that you might do, and it can be non-destructive testing in this case. Then we can use it for the inspection for in-service damage. We can use it for verifying proper processes. We can use it for monitoring and controlling manufacturing processes, and we can use it for verifying proper assembly. The objective of the non-destructive testing, as suggested by the American Society for Non-Destructive Testing in 2008, are to ensure customer satisfaction through ensuring product reliability and integrity, and to ensure the safety of the end user. Also to compete within the currently evolving market by maintaining a reputation through high quality products and better product design. In addition, we need to minimize the waste, which leads to minimizing the overall manufacturing cost and maximizing the profit. And to ensure the flexibility and adaptation of products to market changes. For the non-destructive testing methods, based on the National Material Advisory Board, we have 6 major NDT methods that has been identified. Visual means, just looking with the eye on the item. Radiation, magnetic, electrical, mechanical vibration, thermal, and chemical, electrochemical. Within these categories, the most common or commonly used methods are the visual, the X-ray as an example of radiation, the eddy current as an example of the magnetic electrical, the ultrasonic as an example of mechanical vibration, the magnetic again as an example of magnetic electrical, and liquid penetrate as a sort of chemical, can be called as chemical testing. The visual method, as we can see in this figure here on this slide, is the oldest and the most common method, and it can vary from simple to very complex. When we say simple, just by looking using the naked eye to verify a break in a certain item or a certain part in a machine, to a very complex remote control robot, especially if the place that we need to get to is very tight, in very tight areas, or it has hazardous material, or if we need to use it like in space. In the radiation method, an X-ray machine or radioactive isotopes is used as a source of radiation, which will have the ability to penetrate the object under testing, showing cracks and other defects as shown in this figure here. So the results will be recorded into a film that can be developed into a radiograph showing those defects. The problem that X-ray can affect the health of the people performing the test. Appropriate precautions and policies have to be followed in order to protect the users or the people performing that test. Also, the radioactive waste should be also taken into consideration for environmental and biological reasons. For the magnetic electrical, we said that as an example of that, we have the eddy current, which is a type of electromagnetic non-destructive testing method in which electrical current are generated in conductive material by an induced varying magnet field. So we have a magnetic field that changes, producing electrical current, and that will be used to test the material that I have. The variation of the object are reflected into a nearby coil, and in this type of testing you can use it for detecting surface cracks and make electrical conductivity and coating thickness measurements. This method works only with conductive material, and the surface of the material must be accessible. As another example of the magnetic electric non-destructive testing, we have the magnetic not non-destructive testing, which is a type of testing that is conducted on ferromagnetic material. When we say ferromagnetic material, that means it can be magnetized due to their atom properties, such as iron, nickel, cobalt, or some of their alloys. The test includes applying a magnetic field onto the ferrous object while coating it with iron particles, either dry or suspended in a liquid. The surface imperfections will distort the magnetic field, accumulating iron particles near these areas. And we can see how the green highlight here shows the accumulation of the particles of the iron particles in the crack or the imperfection area. As an example of mechanical vibration, we have the ultrasonic testing, which is a method that can be used in a non-destructive testing environment. It has a high frequency sound waves that can be sent through the object, and the received echo will determine cracks or imperfections in the material or the object that we are testing. The figure here shows how the ultrasonic sounds or ultrasonic vibration has been sent through the material and received, and if we have a flow like we see with the red highlight here, it will reflect that in the system, showing that there was some kind of obstruction in the material or flow in the material or a break inside the material that will show on the screen. The liquid or dye penetrant is a non-destructive testing that is considered as an extension of visual testing, because once we use the material, actually we're going to use the normal sight to look at the items. Maybe we can look at the item in a dark environment and it will glue in the dark, or maybe in certain using a certain ray or light like ultraviolet to see the imperfections in the object. So it is used to detect surface breaking flaws in any non-absorbent materials. We don't want the material to absorb the dye or the liquid that we are using, and the object has to be cleaned thoroughly, then soaked in a fluorescent or visible dye solution. When viewed, it will be viewed in dark, or it can be used, like I said, I can use ultraviolet light or other light waves to look at the dye and identify the imperfections in the object. The other type of testing is the destructive testing. And as we stated before, destructive testing is a method of testing that will put the sample object under certain circumstances until it actually fails. So in the destructive, we are destroying the object. Destructive, we are destroying the object. Non-destructive, we are not destroying, we're just checking, inspecting, and testing the different functionalities without destroying the object. The destructive testing is used in metal testing, such as testing the strength of welded parts or other metal characteristics by strengthening or by stretching or bending those materials. This type of testing is commonly used in automobile manufacturing testing, where they crash the car from different angles and check on the level of protection that will be provided, in addition to the different functions that's needed during such an accident. For example, if we look at the airbag deployment in a car. The most common destructive testing methods are the tensile testing, the force testing, and the hardness testing. The tensile testing, which is also known as the tension test, is the method of determining the behavior of the material under axial stretch loading. As we see in the picture here, we are pulling that material, or they are using a machine to pull the material apart and see when does it break apart. So it's more of testing towards the tension of the material. The data from the test are used to determine the elastic limits, the stretching, the modulus of elasticity, the proportional limits, the reduction in area, the tensile strength, the yield point, yield strength, and other tensile properties. For the force testing, it includes free bend testing, guided bend testing, neck breaking testing, impact testing, and crash testing. For the free bend testing, it's designed to measure the flexibility of weld deposit and the heat affected area adjacent to the weld. When you weld a piece of metal, you are heating the area surrounding that weld. So the particles or the atoms of that material, due to the heat, it might be affected and it might break over time. That's why we need to make sure that welding that part of the object will not affect other parts. For the guided bend testing, it's a type of test used to determine the quality of the welded metal at the joints. We look at the joints and make sure that is the welding here correct? Does it break? So we want to make sure that the welding was actually joining two pieces and we have no problem with that. And we have the neck break testing, which is used for determining the internal quality of the weld metal. It will detect whether internal defects exist, such as slag, inclusions, gas pockets, lack of fusion, and oxidized or burned metal. The impact testing, which is used to test the ability of a weld to absorb energy under impact without fracturing that object. It is considered a dynamic test in which a test specimen is broken by a single blow. It's useful in finding out whether any of the mechanical properties of the base metal were destroyed by the welding process. The crash testing is performed to ensure safe design standards in crash compatibility, and as we said before, It's used in the automobile industry more often, and mostly to check on the car reaction, or what's going to happen to the car during such an incident, or during accidents. They look at the different parts, how would they function, and what kind of protection would they provide for the user, especially the airbags. The hardness testing is a testing that is performed for the metal, to check the metal resistance to bend or scratch or abrasion or cutting. Relative hardness of mineral to resist scratch, for example, can be assessed by reference to the Mohs scale, which ranks the ability of material to resist the scratch by another material. Functionality testing objectives. For functionality testing, which is used to verify whether the product meets the intended design specifications, we look at the product to make sure that the product with the minimum number has the minimum number of bugs or problems, and we would like to ensure that the product will function as intended. Of course, we need to minimize the cost of service and maintenance after sale, and not to break exactly after sale. And we would like to enable product to compete in the market, making sure that it has all the functions and all the features that's been specified by the customer or needed by the customer. And I like this sign when we look at the functionality. Is it functioning well? But I think it's functioning well because it says good luck under that. So yeah, good luck with the functionality testing for your product. Functionality testing can be performed on services or software packages too. Functional testing is also performed in manufacturing facilities through some common testing methods, such as tension, which is the act of stretching an object using an external force to measure product durability; torque, which is a vector that measures the tendency of a force to rotate an object about some axis; and compression, which is the act of applying axially directed pushing forces on a certain object. The different types of hardness testing includes Brunel, which is a type of hardness testing that is based on applying forces on an object using a steel or carbide ball. The Brunel hardness number is calculated by dividing the load applied by the surface area of the indentation, as you can see in this figure, where we have the force or the applied force from the ball divided by the surface area that was indented. Compared to other hardness testing methods, it makes the deepest and widest indentation, which will make it more accurate. But still, it cannot be used for all kind of testing. Another type of hardness testing is the Rockwell test, which is also a test that applies force on an object, as we can see here in the figure, to create indentation, but using a diamond cone or hardened steel ball indenter. One of the advantages of Rockwell hardness testing or method that it includes the direct Rockwell hardness number readout and rapid testing time. One of the disadvantages include many arbitrary non-related scales and possible effects from the sample object. Types from the different types of hardness testing, we have Vickers. It's another type of testing that was developed as an alternative method to measure the hardness of materials. It does not have the arbitrary non-related scales of the Rockwell method, and it's easy to use rather than or compared to the other hardness tests. It can be used for all metals and for ceramic materials. The advantages of Vickers is the extreme accuracy reading obtained by this test. It's thoroughly adaptable and very precise for testing. The last type of hardness test is the MicroHardness test, which is a testing method that is used for metal, ceramic, and composites. It's useful for a variety of applications where other test methods are not useful. For example, for the very thin material, we use this kind of testing, such as foils. We cannot use the Vickers or Rockwell or other type of testing because of the force that will be applied on those surfaces. And since this is a very thin material, then this type of testing will be better to use. The MicroHardness testing gives an allowable range of loads for testing with a diamond indenter. The testing is done similar to Vickers test, but on a microscopic scale with higher precision instruments. The last test is the usability testing, which focuses on determining if the product is easy to learn, satisfying to use, and contains the functionality that the user desires. Some of the tools that can be used for usability testing is like software tool that is like Drum, WebCat, WebSat. You can use many tools in addition to the normal usability test just by using the product itself. And you can decide, you can give it to certain people and they can decide if it's easy to use, easy to learn, and if it is satisfying or not. Mostly it's used, this type of testing, it's used for software packages, websites, and other services, but also used in a manufacturing environment. Like I said, you can give it to give the product to a certain person and let them test it. The ease of use, the to learn, and the satisfaction from that use. You can use any of these testing methods, and like I said, most likely we will concentrate on the non-destructive testing in this class. I don't want you to break any of your products or pieces here to make sure that it works fine. So just look at the non-destructive, make sure that it's working fine, it's safe to use, it doesn't have any problem, it has all the functionalities, it's durable enough for the user, and whatever testing you have, collect the data, analyze it, graph charts to give me an idea on the different testing methods and results that you got, and recommend for your customer based on that, recommend the use for that product. Like I said, for example, if you tested the table to see if it can handle up to 200, then you will say it has been tested with a maximum of 200 pounds, it is recommended not to use it, or not to use a weight above 200 on that table. This is just an example. Again, you look at your product and give an example the same in the assignment, report it with this kind of reporting method or format, where I would like to see actually what's your recommendation for the testing that you did. That will be all for this session. Thank you and have a great day.